So for a solar panels or solar cells, their running cost is low. Running cost means like you don't have to buy anything, any fuel. So running cost is low, but initial cost is higher to build this whole system. Initially, you have to spend a lot of money, but this will last for a longer period of a time because does not require any maintenance, continuous maintenance work. So that's why the running cost is too low. Is it clear? The first thing we discuss, the energy generating electricity by a renewable energy source, that is solar energy. Then the second one, we can also use wind turbines or wind energy to generate electricity. So what happened first, how this wind energy is produced? So as we know, the sun is providing heat energy to both land and sea. Because the proportion or amount of sea is much higher, or water is much higher on the surface of earth as compared to land. So land cannot absorb too much energy. So there are molecules of air above the land and there are molecules of the air above the sea as well. But because the land cannot absorb too much energy, so that's why the molecules of air above the land will become hot. And if it's hot air, the hot air will rise. So as the hot air will rise, the cold air will take position of the hot air, and this movement of the air is known as wind, and the energy carried by these air particles known as the wind energy. So we can also use this wind energy to produce electricity. So how we can use this wind energy to produce electricity? For this purpose, we use windmills or turbines. So as the moving air, there's a movement of the air. What is the concept of the wind energy? Because what happened, the sun is providing heat energy to both land and sea. But 70% is water and you have 30% land. So land cannot absorb too much energy. So as the land cannot absorb too much heat energy, the air above the land will become hot and hot air will always rise. So as the hot air rise, because now there are few air molecules, so cold air or molecules of the air will move from above the sea towards the land, and this movement of the air molecules is called wind, and energy which they carry, we call that as wind energy. So what happened, as there's a moving air particles, these air particles hit this turbine windmill. When it hits this windmill, it causes a rotation or it rotate. So when this will rotate, it is connected to a device called a turbine. And whenever a turbine rotates, turbine is connected to a generator. So the generator will produce electricity. Turbine will not produce electricity. Turbine is only a moving part which rotate, cause the electricity or production of electricity in a generator. So wind turbines convert the kinetic energy in the wind into a mechanical power, and the generator in the wind turbine can convert the mechanical power into electrical energy. So these windmills, they are built or placed or located at the place where it is a continuous movement of the air. So when it is a continuous movement of the air, these air molecules apply force on these wings, so they start to rotate. When they start to rotate, it is connected to a turbine. Inside there is a turbine, and that turbine is connected to a generator. So generator will produce electricity. What is the change in energy or energy conversion? So first there is a kinetic energy of the wind, then it changes into mechanical energy of turbine and generator, mechanical or kinetic, and then it produces electrical energy. The block diagram means the devices which we are using for this process. We use wind turbines, we use generator, and we use transformer. What is the purpose of transformer? Just now I discussed, transformer is to supply electricity from one place to another, because you're not living next to a power station. Power stations are built far away from the residential site. So that's why to transfer energy from a power station to the consumer or residential areas, we use transformers. What is the advantage, or what are the advantages of using a windmill? Number one, it is renewable and it does not pollute the environment. But what are disadvantages? Its wind is irregular, means like someday you have a higher wind speed, next day, like on day one, you may have a higher wind speed as compared to day two. So the output electricity will be different. That also produces too much noise when these turbines are rotating. It's too noisy. They occupy a lot of space like solar cells, and the power generated by this is relatively small as compared to other power stations. Is it clear? The windmills are using a wind energy to generate electricity. Any
Sir,
doubt in
I
this?
have a question.
Yes.
Why do we convert the kinetic energy to mechanical energy? Like, what's the difference?
No
They're
difference.
both like kinetic.
Mechanical energy is a common term, Mohsen. Mechanical energy is a common term which can be used for both kinetic and potential. It's like a common noun for kinetic and potential. Specifically, I say kinetic if it's a moving. If changes the height, I say potential. But if I want to use a common term for either of them, I can use mechanical energy. So wind energy cause the turbine, the blades of the windmill to rotate. So it convert into kinetic energy of the windmill. And then this kinetic energy rotate the turbine. Sorry. So moving air will have kinetic energy. Moving air will have kinetic energy. It rotated the wings, that will also have kinetic energy. Inside this, there's a turbine. That turbine also rotate, and this turbine rotation produces connected to a generator, produce electricity. Is it clear, Mohsen?
Yes, sir, clear.
Then the geothermal energy, the energy from the core of the earth, or heat energy from the earth, is called a geothermal. How earth core is producing energy? This is a top layer, the crust. Then the second layer is the mantle, and the third, the central layer, which is very hot, that's the core. So what happened inside the earth? This is the earth inside. So inside the earth core, there is a nuclear reaction because there are many elements present which can undergo a nuclear reaction, and it is mainly nuclear fission rather than fusion. So due to this nuclear reaction, what it produced? It produced heat energy. And from how this heat energy is released, this heat energy is released by volcanic eruptions. That is why you will find there are places on earth which are still have active volcanoes, but the number of active volcanoes are small now as compared to what was there in the past. Reason for that, because the continuously the core, it undergo a nuclear reaction, so it is producing enormous amount of energy. And these volcanic eruptions, the volcanoes help earth to release this energy. Like if this is a volcano on the surface of the earth, so because volcanoes have openings, so this energy can be released. Otherwise, what happened if there were no volcanoes? Then this energy reach a certain point that earth surface cannot hold this energy, and earth will explode. So to overcome this, there are active volcanoes which reduce the heat energy, so earth can be stable. Now what happened? How we can use this energy to produce electricity? So for this purpose, we use underground pipes, and from one side we add water. So we add water from one side. As the water is added, this water, what will happen? This water will absorb the heat energy from the core. So when this water will absorb the heat energy from the core, this water will convert into steam. So the water enter, but the steam is coming out. And when this steam is coming out from the other side we place a turbine. So a turbine is placed other side. When the steam is coming out, so this steam will push this turbine. So what happened? The turbine will rotate. And this turbine is connected to generator. Because turbine does not produce electricity, generator produce electricity. So turbine connected to a generator, and when there's a movement of the coil in the generator, it will produce electricity. But this cannot be done every place, because the surface, the texture of the earth surface at different places, it's different. Like some places you have a soft ground, at that location it can be done, or the place nearby volcano, this can be done easily. But hard grounds, it's difficult to do this or carry out this method, because several kilometers we have to do a drilling and then put these pipes so that we can add water which absorb the heat energy from the earth core, release from the earth core, and convert it into steam. The purpose of the steam is to rotate the turbine. Steam will collide with the turbine. So as steam, because steam will apply more pressure. So as the steam will apply more pressure on the turbine can rotate. As the turbine can rotate, it is connected to a generator which produces electricity. So I'll repeat again, look what happened. The core of the earth is producing heat energy. So as the core of the earth is producing heat energy, this heat energy is absorbed by the water which we add from one end. The water absorb energy, water will convert into steam. Reason why the steam is useful here, because steam apply more pressure as compared to normal water. So as steam will apply more pressure, This steam will rotate the turbine, and as the turbine rotates, it is connected to a generator, produce electricity. Is it clear? The geothermal energy. Why we call geo? Geo means earth and thermal means heat. So heat energy from the earth is called geothermal energy. So you can see here, this is a picture which shows. So earth core is there, the heat energy. This heat is coming from the core of the earth. We have these underground pipes. So we add a water. When we add a cold water, the water will absorb energy from the earth. We add cold water, water will absorb energy which is released from the core of the earth, and it will convert into steam and hot water. And when this steam will reach at the top, rises up, it collides with a turbine, and this turbine is connected with the generator which produce electricity, and we transfer that electricity to the consumer or residential areas. Any doubt in this? Is it clear? The concept of geothermal energy?
Yeah, it's clear.
Yes, sir.
So what is the energy changes? What are the energy changes here? Number one, the geothermal energy or heat energy converted into kinetic energy. What is the why kinetic energy? Because you can see the steam start to move. It absorb energy and it start to rise. So it will have a kinetic energy. Then the steam collided with the turbine. So mechanical energy or kinetic energy of a turbine and generator, and then it will produce electrical energy. At the last, all are electrical energies because we are using them to produce electricity. What is a block diagram? Means what are the devices which we are using for geothermal power stations, or what are the things which we are using? Hot rocks are used, turbine. Hot rocks here refers because we are taking energy from them, and then generator. And then transformer is to supply energy from one place to another. The purpose of the transformer is power transmission. Like this part, at this part we add a transformer so we can supply energy from one place to another. What are the advantages of using this geothermal energy? Block diagram means the things, the devices which you are using for this power station. The components which you are using for the power station refers to block diagram. So this renewable, the advantage, it is renewable. Low running cost because we don't have to add any fuel, and it has had high power, can be generated by this geothermal because too much heat energy is produced. Disadvantage, pollute the atmosphere by releasing the steam. How steam is polluting the atmosphere? So how steam is polluting the atmosphere? Because steam is also, or water vapors are also refers to greenhouse. What happened? Because as this steam is coming out, this steam is released to the atmosphere as well. So, and this can also increase the average temperature of the atmosphere because it's a hot water vapors. That's why it is polluting the environment in terms of vapors. Then this technique is very expensive process. It's like it costs too much to build these geothermal power station, and it also destroy the land area, because to build this geothermal power station you have to first do a drilling and deep inside this earth layer. So this land will not be useful for anything. Is it clear? The geothermal power station, any question? Then next is hydroelectric energy. What is hydroelectric energy? This is also the hydroelectric energy. Also, it is due to the sun. How this hydroelectric energy is from the sun? Because what happened? A sun is providing heat energy. So there's a evaporation, a process of evaporation which have occur at the surface of the, so at the sea level, or water from the sea evaporates. As this water evaporates, it's a water cycle basically. It will condenses and form clouds, and when from these clouds it rain at higher altitude or mountains. So when it rained at a higher altitude, because the water is at certain height, whenever something is at certain height, it will have gravitational potential energy. So why the water is having a gravitational potential energy? What is the source here? The source is the sun. Sun is basically responsible for gravitational potential energy. Why? Because the heat energy from the sun is absorbed by the water. The water will vapors, it will form water vapors. As the water rises to certain height, it will have gravitational potential energy. So sun is a source of hydroelectric energy. How we can use this hydroelectric energy to produce electricity? So as this water will flow, this will be a river, and this water will flow back from river to sea. So what we can do, we can build a wall here to stop the flow of the water. So when we build a wall to stop the flow of the water, we call that as a dam. Dam means like the place where you're storing a water or a reservoir of a water. So how we build a dam? By building a large wall so that it can stop the flow of water. So when this water stopped by the wall of this dam, so the water level will rise. So as the water level will rise, the water will have which form of energy? Because the water level rises. So which form of energy this water will have? What is the form of energy when the water is at certain height? So it will have potential energy or gravitational potential energy. Then what we do, we allow this water to flow. So as this water will flow, we can build a wall, we can build a turbine here. There's a gap, and then we place a turbine. So because the water is at certain height, so it will have potential energy or gravitational potential energy. In this wall, there are doors to open, or the doors for this wall, which allow the water to flow. So when we open these doors, the water will come out. So as this water will come out through these doors, it causes the rotation of a turbine, and as the turbine rotates, it is connected to a generator which will produce electricity. So heat energy from a sun evaporate the water. This water, we stop the flow of the water by placing a wall or building a dam. The purpose of a dam is to store water. And when we open the gates of a dam, the water flow through these gates and rotate the turbine. And as the turbine rotates, it produces electricity. Is it clear?
Sir, I have a question.
Yes.
Sir, like the optimal position of the turbine, it should be at the bottom of the dam, right?
Yes, right.
Because of the pressure.
Because of
So
pressure
that,
as well. Yeah, that's correct. And greater change in potential energy as well.
sir, the
But
greater
for
change at the lower.
no, not temperature, potential energy, greater change in potential energy.
Sir,
Because
but it's lower.
no, the turbine is at lower position, but the change in potential energy is higher. What is the reason? Like example, if I give you, these are the two walls of the dams filled with same amount of water. Example, the height of the height of the wall is, example, 10 meters. Okay. And in the first one, I place a turbine at a height of 2 meters. And the second one, I place a turbine just at the bottom. So which one you think will produce greater amount of electricity? A or B?
Sir, I think B.
B. So what is the reason? Because the first one, there's a smaller change in potential energy. The water will flow out through this. The water will flow out through this dam, but once it reaches this level, it will stop flow. The flow of the water will stop. So only the change in the potential energy is due to 2 meter height. Only 2 meter height change. But what happened when I place at the bottom? So greater amount of or greater change in height is there. Greater change in height. So what happened? It will have a greater change in potential energy. So about approximately 10 or 9 meter change in height, greater amount of water will flow. So placing a turbine at the bottom will give you more output as compared to at the top. Is it clear?
Yes, sir.
Yeah, it's clear.
So when we compare these hydroelectric power stations, we can see here, this is a real picture of a dam. So this dam is having gates also. What is the purpose? But practically, there's a constraint like building the turbine or gates at the bottom. Reason for that, why practically it's not done. Otherwise, the strength of the wall will be, or wall will be weaker, which is storing the water. That's why it is not exactly placed at the bottom.
So like the holes at the bottom compromise the strength of the wall or
Yeah,
the dam.
that's because strength is more important. For example, you want to generate electricity and you place the turbine at the bottom, but the wall of the dam may break after 2 days, then it's difficult to build the wall again. That's why it is compromised and placing the turbines at a certain distance, optimum distance, so that we can generate electricity.
Yeah, okay, so
So you can see here the water is stored behind the dam, and when we allow this water to flow, open the gates for this dam, the turbine connected, which is connected to a generator, produces electricity. What are the energy changes here? The gravitational potential energy, the potential energy of a water changes to kinetic energy of a water, then turbine, and then electrical energy. Then a block diagram, the devices which we are using, the components, we use dam here, we use turbine, we use generator, and we use transformers. What is the advantage of using hydroelectric power station? So low running cost and renewable. And what are the disadvantages? What are the disadvantages? So building a large dam causes flooding of a vast area, because what happened? The place where you build the dam, not low electricity, generate enough electricity. Most of the renewable resources, electricity generated by this hydroelectric. So building a large dam causes flooding of a vast area, because the place where you build these dams, so there will be too much, yeah, environmental impact. That's also correct. High building cost is there, because building a wall, water pollution. How it causes a water pollution? Because as you build this wall, the water, as it spread throughout the area, there's a flooding, so water will absorb different nutrients, or it may have dissolved lot of unwanted salts. That's called the water pollution, and it also destroy the natural lands. So there are advantages and disadvantages both for these. Now, generating electricity from non-renewable resources. Non-renewable resources means resources which cannot be replenished over a short period of a time or used up. Example, fossil fuel or coal power station. So what we do in this fossil fuel or coal power station, this one we'll discuss next class. I will share some questions with you. Question 13. Which boxes, the box contain a name of 8 different energy resources. How many resources are renewable here? How many of them renewable? Natural gas, it is
4.
renewable. Natural is not renewable. Geothermal, renewable. Solar, renewable. Wave, renewable. Coal, non-renewable. Wind, renewable. Hydroelectric, renewable. Oil is not renewable. So 1, 2, 3, 4, 5 are there.
Oh.
Wind or wave energy is also a renewable energy. Wave
Yeah,
is
how
the
is
energy.
waves renewable?
Wave is the energy caused by the moving air. So if wind is due to the sun, so wave energy is also due to the sun. Because what happened when the air particle moving over the surface of the water, it produces waves. So moving air is responsible for wind energy as well as wave energy, and both are from the sun, so that's why it is renewable. Which device is designed to convert a chemical energy to kinetic energy? Which one of them is converting chemical energy to kinetic? It use a fuel and it start to move. So a car engine, because a car engine, it's use chemical and convert it into kinetic energy. Any question related to a class today? More questions next session will
Sir, I
discuss.
have a question.
Yes, Mohsin, less than a minute left. So
Okay,
continue.
sir.
No, you can ask your question and
Sir,
then just,
like,
yeah.
yeah, okay. Sir, so why is heat involved with solar panels? It's just the photons
But the
of
thing,
the light.
a photon is actually a particle which carry energy. So heat also can be carried by a photon.